G'day guys, we're transforming functions today. We've been given this cubic function here, and by the looks of it we're having to find the equations of two cubic functions that result once we've done these transformations to the initial cubic function up here. So let's see what we've got to do. So we have an initial function that is f of x equals x cubed minus 4x squared plus 8x minus 5. Now we have to give a horizontal dilation of scale factor 2 and a horizontal translation of 3 units left. Okay, so basically what we have to do here is the first thing I would start out with going is we've got our part A. Now, what we're going to do is we're starting with the function f of x. Now, what we have to do is we have to dilate this function by scale factor 2 in the horizontal direction. So if it's in the horizontal direction, it means we have to multiply the x value by a particular amount. Now, to get to dilate by a scale factor of 2, we have to do the reciprocal of that inside this bracket. So the first transformation we're going to have to go f of a half x, or x over 2. So this is our first transformation. So that's us dilating it a scale factor of 2. Now we have to have a horizontal translation 3 units left. Now when we translate horizontally, we have to do it by the opposite of the way we're going. So 3 units left, or we're going this way by 3 units. That's going negative 3 units. So what we're going to have to do is inside the bracket, we're going to have to, rather than go negative by 3 units, we start with this x over 2, we have to add 3 units. And this is going to be what our final function will look like. Okay, now from here you might be asking, well, that's all well and good, but what's the cubic function that results? Alright, well, let me show you how that will work. Because what we've done here, in both cases in this transformation, we've worked on the x inside the bracket. So what we're going to have to do is we're going to have to replace the x in the old function with this new x value. So you'd almost call this like, this is a new x. Okay, so the way that we're going to do that is we're simply going to just substitute this into here. So we're going to have x over 2 plus 3 cubed minus 4 x over 2 plus 3 squared plus 8 x over 2 plus 3 minus 5. Cool, so you can see that I've just substituted this new x value into the equation for the x value. So obviously the y-intercept term, it's not going to affect that because we haven't, it doesn't have an x term with it. So what we then have to do is we have to go through the tedious process of expanding all of these brackets out. So what I'm going to do is I'll just expand these brackets out. You can use a calculator, or if you know how the expansions work using a Fibonacci triangle or something like that, Pascal's triangle, sorry. You can do them by hand, but usually you'll use a calculator to expand these parts. So let me just do the expansion for you. Okay, now we're going to multiply out these brackets. And now we're going to combine our like terms. So we have x cubed on 8, there's no other x cubed term. And we have 9x squared on 4 minus x squared, so that's going to be 4x squared on 4, so it's going to be 5x squared on 4. got 27x on 2, which is 13.5, minus 12x is going to be 1.5 or 3 over 2x, plus 8x on 2. So 11x over 2. And we have then 27, take 36 is negative 9, take 5 is negative 14. So this is our new cubic function. Cool. So you can see that it's quite laborious to actually get a final answer. And this question would be worth quite a few marks if you weren't able to use a calculator to do it, because to do these expansions here takes quite a lot of mental arithmetic, and there's quite a lot of places you could get it wrong. But I think you'll find that part B is a bit easier than part A, so let's just go about doing that now. Okay, part B. So what do we have to start with? Well, we've got a vertical dilation of scale factor 3 and a reflection in both the x and y axes. Okay, so the reflections in both the x and y axes will give us, we have to make the inside term negative and we have to make the outside term negative. And a vertical dilation of scale factor 3 is that we have to just multiply all of the y values by 3. So the way that we're going to do this is we're going to have f of x is going to be transformed to negative 3f of negative x. Now these negatives here give us this one here is a reflection in x, this one in here is a reflection in y, and this dilates it in this direction. Cool. So let's go about figuring out how this is going to work. So what we're going to do is we've got this function here. We're going to have to multiply the entire function by negative 3. So that's what we're going to start with. So we're going to go, this is equal to negative 3 multiplied by. Now, instead of putting x, we have to substitute in negative x. So this is going to equal negative x cubed minus 4 bracket negative x squared plus 8 negative x minus 5, close bracket. Cool, so what I'm going to do first is I'm going to multiply out my brackets, the inside brackets. So I'm going to still have negative 3. Negative x cubed is still negative x cubed. Negative x squared is just x. And then we've got take 4. So we've got minus 4x squared. 8 times negative x is negative 8x, and then we have minus 5 on the end. Cool, so finally we just use the distributive law to multiply into the bracket with the negative 3. Negative 3 times negative x cubed is just 3x cubed. We have negative 3 times negative 4 is plus 12x squared. We have negative 3 times negative 8, so we have plus 24x. Negative 3 times negative 5 is plus 15. And that, guys, is the answer to the second one. As you can tell, because we haven't had to do any multiplication or anything on the x, there aren't any complicated expansions of brackets that we have to do, which take a lot of time to algebraically expand all of these things. So you can see that what happens is if we change anything on the inside of the bracket in this functional notation, we have to just replace the x with the value. If we change anything on the outside of the functional notation, like this negative 3 here, Once we get the function written down, we put it in a bracket, and then we multiply the entire thing by either a negative number or a number, or we can add 3 on the end if we're shifting it up or down. But in most cases, you're going to either change the x value, so put a bracket where the x used to be and then put the new x value, or you're going to put a bracket around the entire function and either dilate it or transform it using a multiply or an add or a subtract. So I hope this video helped, guys, just get a understanding of the mechanics of transforming these functions. We don't have to even know what they look like to start with. We can just use our algebra methodologies to just get from A to B. So again, thanks for watching, guys. If you liked it, definitely subscribe to my channel. I put out new videos as often as I can. Give us a like, helps me out a bit, gets people watching my videos. And until next time, enjoy your maths.